Our next device is inductor. So here again we are not going to discuss the physics stuff of inductor. We will only see its characteristic, which is helpful in analyzing the circuit. So for that you refer any physics textbook. There you will get working principle of an inductor, etc. Okay. So in inductor we can define its behavior like this: flux linkage. Flux linkage associated with or produced by it is directly proportional to current flowing through it. Current flowing through it. So if you call psi as a flux linkage associated with an inductor, it is directly proportional to the current flowing through this. So more current flows, more flux linkage will be produced. Now this, if I use proportionality constant, it will be L into I, where L is inductance, Now if you take again a differentiation with respect to time both side, so d psi by dt equal to L times di by dt. So d psi by dt, it is nothing but a voltage. So voltage induced or voltage produced is nothing but d psi by dt, and that will be equal to L di by dt. So this is the relationship between voltage and current in an inductor. So voltage generated or produced across inductor is equal to L times rate of change of current. Okay, so that is V equal to L di by dt. So again, if you want to have an expression for I in terms of V, then if you take a di this side, that equal to 1 over L V dt, and if you integrate on both sides from a time interval t equal to t0 to t equal to t, then what we get is I of t minus I of t0, that is equal to 1 over L integration running from t0 to t v dt, or I can write I of t equal to 1 over L t0 to t v of t, we can write v of t dt plus I of t naught. So current flowing through in the inductor is nothing but 1 over L, and you have to integrate from t0 to t, the time interval, v of t with respect to dt plus the initial current at t equal to t0. What was the current? That will be added. So this is the equation for the current. Now, but what we are interested in, the characteristic of inductor, which we will use in the solving problem. So that we will see here. So characteristics of inductor. First one, there is no voltage across an inductor if the current through it is not changing with respect to or with the time. So we can write that no voltage produced no voltage across an inductor if current through it is not changing with time. So that means it is a short circuit. So that means inductor is a short circuit for DC. So no voltage means zero voltage. Zero voltage, how we can represent a short circuit? So if a DC current is flowing through or current is not changing with the time, then it can be replaced by a short circuit. So for DC it acts like a short circuit. And second one is very important. An inductor resists abrupt change in current. Abrupt change in current through it, which requires infinite voltage. So this is the application of this characteristic we are going to use in the problems. So what does it mean? If a current I naught is flowing through in an inductor at t equal to 0, and if you want to change the current through it at t equal to 0, what happens? Soon after you apply the external force, that is t equal to 0 plus, the current through the inductor will not change. Whatever current is flowing at t equal to 0, same current will flow at t equal to 0 plus, where t equal to 0 plus indicates what? Soon after that moment, soon after t equal to 0. So that means you cannot change current flowing in an inductor instantaneously, but in resistor you can do. If some current is flowing through in the resistor, if you change voltage or if you change the current, you can easily get the result there. But in inductor you cannot change instantaneously current. Similarly with capacitor, you cannot instantaneously change the voltage. So this is very important. It's a second characteristic. Third one, an ideal inductor does not dissipate energy, but only stores it. So an ideal inductor, if you see, it will not dissipate in the form of heat, it will store it. However, in practical, it will have it will have parasitic resistance, and you will see the dissipation of heat. So energy will be dissipated in a practical inductor. Okay. So now using this property number 2, we can write the initial condition with respect to the inductor. Okay. So we will write initial condition. Suppose you consider an inductor with I equal to 0 at t equal to 0. So at t equal to 0, no current is flowing through the inductor. No current is flowing. Now what you do at t equal to 0, you would like to change the condition of the circuit. You would like to apply some current. So at t equal to 0 plus, though you have applied or though you have changed the condition in the circuit, the soon after t equal to 0, that is t equal to 0 plus, that instant of time current through the inductor will not change. So current through the inductor will not change means here zero current is flowing. How you can show zero current or no current is flowing through? Because inductor cannot change its current instantaneously. So that we can represent using an open circuit. So inductor will act like an open circuit at what instant of time? At t equal to 0 plus. At later it will allow, so current will flow through that, but at the t equal to 0 plus instant, no current will flow. It can be modeled as an open circuit. Similarly, if an inductor is carrying I equal to I naught current at t equal to 0, this time the same principle, the current cannot change. Previously 0 current, now I naught current. So it will be represented by a constant current source with I naught. This also I can, open circuit also I can write, represent as a current source with I naught equal to 0. That's an open circuit. Both are same. I can represent like this also. But here, since it is carrying a current I naught, it will continue to carry that current soon after this instant of time, t equal to 0 plus. It will carry the same current. And if you keep if you apply a DC current or voltage, if you apply DC current to the inductor, then at t equal to infinity, or we can even call this one steady state. Steady state means you apply a DC source and keep quiet. So after certain amount of time, it will attain a steady state. So in the steady state, how inductor will behave, that we have already discussed in the characteristic. What is that? The number 1, characteristic number 1. No voltage across an inductor if current through it is not changing. So if you are applying a DC current, so then if you are not changing current with time, then it can be modeled as a short circuit. So if inductor, a DC current is flowing, it can be modeled as a short circuit. What does it indicate, short circuit? Short circuit indicates voltage across inductor is 0. To indicate that, we are using short circuit. Okay. So if you keep an inductor as it is for long duration of time, after steady state, when you are applying a DC current source, then the voltage across inductor will be 0 and it can be represented as a short circuit. Okay. That is about the inductor. So we have discussed capacitor and inductor. Now we will see first order RL and RC circuit.